Welcome to the Minnesota Engineering by Design video series. I am Michael Sandell, Consortium Director for Minnesota EBD. The Minnesota Engineering by Design project is a partnership between the Minnesota Technology and Engineering Educators Association and St. Cloud State University. We have joined the International Technology and Engineering Educators Association's STEM Center for Teaching and Learning to be part of the National Engineering by Design Consortium. In December of 2019, MTEEA and St. Cloud State University made a commitment to bring the Engineering by Design program to Minnesota. The decision was based on the need for an engineering curriculum option that was flexible, affordable, and accountable, a program that could be modified by the instructor to meet the needs of the school system. Engineering by Design offers a premier standards-based curriculum model that met this criteria. The Pre-K-12 curriculum is based on the standards for technological and engineering literacy, as well as national standards for math, science, Common Core, and the NAE's Grand Challenges for Engineering. Engineering by Design was developed to actively involve students in the learning process through completion of project-based learning activities. Through the entire learning process, students continually collaborate with team members. The Engineering by Design curriculum is designed so that the teacher can adapt the materials to fit the time schedule, facility capabilities, and needs of the classroom. Engineering by Design is an integrative STEM program that teaches content and practices of science and mathematics education through the content and practices of technology and engineering education. The Engineering by Design program was developed by the ITEEA STEM Center for Teaching and Learning. The program goes through a continuous improvement process with the recommendations of the EBD State Consortium members. Through this yearly process, curriculum changes and rewrites are made based on the recommendations of the members. One of the major changes is that each course is going through a process to make it more student-facing, with pre-recorded presentations by the course authors. Engineering by Design is a standard-based model program based on the following standards: the standards for technological literacy, benchmarks for science literacy, principles and standards of mathematics, and STEM knowledge and skills statements. The Engineering by Design program uses a learning model that is an adaptation of the Biological Science Curriculum Study 5E learning model that adds a 6th E, engineering. While capital E engineering is for a limited audience, those who are working to become engineers, Engineering by Design teaches lowercase e engineering, the engineering concepts that all students should know. The teaching and learning of these engineering concepts will also prepare students for capital E engineering programs in the future. Engineering by Design is presented in 3 levels: Pre-K-6 TEEMS, middle school grades 6 through 8, and for high school grades 9 through 12. We will look at these programs in the next few slides. The Pre-K-6 TEEMS program provides a unique opportunity to introduce and refine the knowledge and skills for understanding the design world that is equally important during the elementary years. Children have experiences in design at the earliest stages of development. Ingenuity is a natural human trait. It needs to be nurtured, developed, and refined. Designing solutions to specific problems is the application of ingenuity. Add to this ingenuity several resources, parameters for design solution, and some guidance, and children begin to display an interest in and ability to understand the design process. Developing these interests and abilities creates the foundation for understanding technological development and innovation. In order to comprehend the attributes of design, students in grade K-5 learn that the design process is a purposeful method of planning practical solutions to problems that includes creating ideas, putting ideas on paper, using words and sketches, building models, testing the idea, and evaluating the solution based on the requirements. Requirements for design include such factors as the desired elements and features of a product or system, or the limits that are placed on the design, such as, but not limited to, size, cost, type of material, weight, color. All building blocks in the EBD TEEMS curricula are designed for flexible use to meet the varying needs of today's elementary classrooms. While it depends on the frequency and duration of time allotted for STEM learning experiences, each building block should take about 6 to 8 weeks, based on an average of 3 to 4 hours of implementation per week. Some lessons take only 20 to 30 minutes, while others, like the design challenge, take several hours to complete. The estimated time for each lesson is provided in the sequence and description of the courses. The middle school courses are Exploring Technology, Invention and Innovation, and Technological Systems. These 3 courses may be used as designed, completed in an 18-week semester of 50-minute periods, or modified by the instructor to meet the needs of the school system. Engineering by Design coursework does have the ability to be flexible to meet the time constraints for class, the available equipment and materials, and the abilities of the instructor. While each unit has activities built in, the instructor can modify the curriculum to use a legacy activity or project, provided it meets the standards of the unit activity. In Exploring Technology, students develop an understanding of the progression and scope of technology through exploratory experiences. In group and individual activities, students experience ways in which technological knowledge and processes contribute to the effective design and solutions to technological problems. Students participate in design activities to understand how criteria, constraints, and processes affect design. The course is a cornerstone for the middle school technology education program. In this course, students learn about invention and innovation. They have opportunities to study the history of inventions and innovations, including their impacts on society. They learn about the core concepts of technology and about the various approaches to solving problems, including engineering, design, and experimentation. Students apply their creativity in the invention and innovation of new products, processes, or systems. Finally, students learn about how various inventions and innovations impact their lives. Technological systems is intended to teach students how systems work together to solve problems and capture opportunities. A system can be as small as 2 components working together, or can contain millions of interacting devices. We often break down the macro systems into less complicated microsystems in order to better understand the entire system. However, technology is becoming more integrated and systems are becoming more dependent upon each other than ever before. Electronic systems are interacting with natural systems as humans use more and more monitoring devices for medical reasons. Electrical systems are interacting with mechanical and fluid power systems as manufacturing establishments become increasingly automated. This course gives students a general background on the different types of systems with a concentration on the connection between those systems. The Engineering for All project was funded by the National Science Foundation to create, test, and revise 2 6-week modules for middle school technology education classes on the important social context of food and water. 2 units were developed: vertical farming and water, the role in crisis. Students in the high school program use hands-on lessons to learn key concepts about engineering, design, invention, and innovation, and the roles they play in creating technological systems to help make life easier and better. The program incorporates the applications of technology, engineering, mathematics, and science concepts, and provides a strong background for students to investigate technology-based careers. The Engineering by Design 9-12 pathway can be designed with the needs of the school system, the facility, teacher, and students in mind. Foundations of Technology is the base course of the series that prepares students to understand and apply technological concepts and processes that are the cornerstone for the high school technology program. Second and third year courses may be selected based on the capabilities of the lab and classroom or available technology. Engineering Design is the capstone course in which students focus on how engineers apply their creativity, resourcefulness, mathematical, scientific, and technical knowledge and skills in the creation of or refinement of technological products or systems. The key approach will be the employment of a sophisticated, sequential, iterative design and development process to solve authentic engineering tasks and problems. By following a suggested pathway, educators can prepare students for a successful attempt at an industry certification through Certiport for the Autodesk software packages of AutoCAD, Revit, and Inventor. Engineering by Design Buzz is a learning management system for the Engineering by Design program. The LMS course content can be modified by the instructor to meet the needs of the school system. Additional materials may be added to the LMS by the instructor. The course content may be imported into other learning management systems using a common cartridge. Course materials are exported using a file system that can then be organized in the LMS used by the school district. The yearly access fee applies to the common cartridge. The Engineering by Design Buzz online learning management system for the Media-Rich Edition courses offers a robust data analytics system. The pre- and post-assessment used in MRE courses are designed specifically to measure achievements of the standards for technological literacy, content standards, and corresponding benchmarks. Students complete the pre-post assessments for an MRE course, and the results are processed in real time. Administrators and teachers can access the results immediately by generating test analytics for the assessment. Test analytic reports include these features. Frequency of score illustrates the score distribution on a bar graph, providing values for passing threshold, mean, median, standard deviations, and quartiles. Statistics list the significant data. Frequency of grade represents a breakdown of data according to the course grading scheme. The data analytics also offers question item analysis, which illustrates item difficulty and discrimination performance for each question and allows users to see how each question impacts score. If you would like additional information on the Engineering by Design program, you can check out our webpage or check us out at mteea.net. We also have a YouTube channel. These are both linked in this presentation. Or contact myself, Mike Sandell, Minnesota Engineering by Design Consortium Director, at the web address there. Thank you for watching this video. Please take time to check out the others as they are made available.